So my Corsair H100i, which you see disassembled here, recently failed on me due to clogging up, and since I had half of the parts to make a custom water cooling loop, I decided that I would just do that rather than go with another all-in-one solution. One of the components I did not have, though, is a temperature controller. As it turns out, the H100i has within it a built-in temperature controller that will function without any interaction from the operating system. In this video, I'll show you how I repurposed the main controller board inside the H100i into a standalone temperature controller for my new custom water cooling loop. The first step is to take out these 4 screws. On the top of the unit, you can take off this Corsair plate by just pulling up on it. And in the front, right up here, there's another screw that needs to come out. So after you've got the case off, it'll look something like this, with the pump wire still attached, obviously. These are pretty easy to remove with a soldering iron. And once you've done that, the board can be taken loose from the rest of the pump assembly. Now, on the bottom of the board, we've got this thermistor here. You want to make sure you don't break that off because that's the most important part of this whole thing. And then we've got a panel, an acrylic panel with the LED, RGB LED shooting in the side of it that we're just going to remove because we don't need it anymore. Now, I've already done the work of removing the solder from this, but you know, it's pretty easy to get off. You can just glob it on there and then pull the RGB off, or you can use solder wick or solder sucker or whatever your preferred method is. The thermistor's holes are spaced 0.1 inches apart, so a regular pin header fits in there just fine. I decided to swap out the thermistor for a pin header on my board. Now, it's important that when you stick the header in, if you choose to do that, you want to have the pins coming out and solder on the front side of the PCB, and that's because the traces from these holes are on the top side of the board, and if you drill it out, you're going to lose the through-hole plating. So if you'd soldered it on the other side, you'd have no connection and, you know, effectively you wouldn't be reading the temperature. So now that we've taken this board out of the case, we've got all these exposed pads on the board which can short out to the case of your computer or, you know, wiring or something like that. So what we really need to do is wrap it up, and for that I'm just going to use electrical tape. I'm going to install the thermistor into one of these plugs so that should I choose to later, I can move the thermistor around to different points in the loop. To install the thermistor, I'm going to drill a blind hole in this plug. I've chosen a drill bit that's slightly oversized for the thermistor, and I've already set the stop on the drill press so that I won't go all the way through it. And there's the result. Now to apply the thermal epoxy. So here's the end result after I finish the epoxy. Not going to win any beauty awards, but it's fairly mechanically strong. The epoxy is just some stuff that I had on my shelf. It's specifically a thermal epoxy. I think I just got it on Amazon, so if you search for thermal epoxy you can find something similar. Once you've got your temperature probe finished and installed, all you have to do is tuck the control board away where nobody will see it. Hook up the controller just the same way as you did before and use the provided software to control your fan speeds.